Okay, let's look at the matrix of this. So we've looked at the cell types: the osteoblast, osteocyte, osteoclast. We've looked at those. So let's look at the matrix of the bone itself. So let's look at this. Let me go here. And the matrix, what we're looking at, is going to consist of two components. So the matrix has two different components. There's going to be the organic component, and then there's going to be an inorganic component of the matrix. The organic component is the osteoid. Okay, and as we know, the osteoid is secreted or comes from the osteoblast. Now, the osteoid is actually made up of basically three different things. We're going to have the collagen fibers, and then we're also going to have the proteoglycans, P-R-O-T-E-O. Proteoglycans and glycoproteins, G-L-Y-C-O. Okay, so the osteoid is made up of the collagen fibers. So remember, connective tissue are cells within an extracellular matrix, and the matrix is made up of fibers and ground substance. Okay, so the proteoglycans and the glycoproteins suspend the collagen fibers. Okay, so that's what we're looking at on this one. And then those components here provide the tensile strength of bone, which resist stretching and twisting of the bone. Okay, so that's the organic component of bone. And let's look at, let me bring this up a little bit. Let's look at the inorganic component of this one. And your inorganic, your primary component of the inorganic side of the matrix is calcium phosphate. Calcium phosphate. Okay, you recall me saying in the past, bone is primarily a storage area for calcium and phosphate. So this is the calcium phosphate. That's what is stored. That's primarily what's found in bones. And the other one would be calcium hydroxide. Okay, calcium hydroxide. And then these two interact to give you crystals of hydroxyapatite. I think I got that right. Okay, hydroxyapatite. Okay, they'll give you, or crystals of hydroxyapatite. And what happens here is this combines with other salts. Okay, it's not just those, but we have other salts, and ions. So those two basically come together and will deposit on the collagen fibers. Okay, so these are the collagen fibers that comes from here. So the collagen fibers, that's what this is portion of. That's what this is. And if you recall from the previous video, I said I used the analogy, if you have a slug and the slime, and if it's raining or sprinkling, the raindrops would be the salt crystals. Well, these are the hydroxyapatite and these other salts and ions. That's the rain that deposits on the collagen fibers. Okay, and this will then lead to hardening. So this is hardens, and then it gives the bone rigidity. Okay, now that's actually how the bones are or hardens and does this. Now we do need a couple things that allow for this process to occur, and all of this requires vitamin D. Okay, vitamin D is necessary for calcium absorption. Okay, for calcium absorption in the gut, in your GI tract, or the kidneys, reabsorption in that case. And so this is where the calcium comes from. And it also requires vitamin C, which is necessary for collagen or collagen formation. So that's how we're looking at this portion of it. So let's look at the bone resorption briefly on this one. So let's look at bone resorption. Okay, and bone resorption, if you recall, what kind of cell is that? Think about it. That's an osteoclast. Good. Okay, an osteoclast, just real briefly, these are multinucleated cells. They originate from fusion of bone marrow cells, similar in nature to monocytes. They're phagocytic in nature. And what we're looking at here is the osteoclast will secrete enzymes that digest the organic component. Okay, so if you recall, let me do this, the picture that we had here. So if you recall, this was the osteocyte, or I'm sorry, osteoclast. Okay, and I think we had green for it's multinucleated on here, something like that. And we said it secretes, let me do purple, something like this. This will actually secrete enzymes that digest the organic component, which the organic component of the matrix is going to be the collagen and proteoglycans. Proteoglycans. Okay, so that will digest the collagen and proteoglycans. But now we also have to get rid of the inorganic or the mineral component. So we also have to secrete something here, which is the hydrochloric acid, which dissolves the minerals, which is calcium and let me back that one up and actually make it look good. Calcium and phosphate. When it dissolves those minerals, it liberates them. And when it liberates those from the bone, it then goes into your bloodstream and raises your calcium and phosphate levels to maintain other body functions. So that's basically how the bone is deposited, or how bones will harden, as well as the bone resorption. So the next thing that we're going to be talking about, I believe, are going to be the functional unit of the cell, which is the osteon.